The square root property. Uh-huh. Here we go. You're so square. Yeah, I'm up here. If I have something squared, it could be stuff, it could be A, it could be anything. And I was trying to figure out what that A was. One natural way to get away from having that square up there is to take the square root of both sides. Okay, you take the square root of both sides. Bam, square root of the left side and the square root of the right side. What you do on the one side, you must also do onto the other. Remember that obscure, arbitrary, well, seemingly at the time, the square root of something squared, that turned out to be the absolute value of something? Oh yeah, I remember that now. So then, you can look at this as, the absolute value of A. Okay, that's gonna be equal to the square root of X. Yeah. Oh man, but then you remember back in the day when we had equalities? Yes, absolute equalities. They broke into two cases, one where the stuff was positive and one where the stuff was negative. Yeah. And to capture all that without the absolute value, we can rewrite this as A is equal to plus or minus the square root of X. Okay, here's the bottom line. What do you need to remember? Yes, whenever you take the square root of both sides, you're not going to forget the plus or minus. You're not going to forget the plus or minus. Okay, let's do some examples. I'm up here. Take a look at this. Man, I want to use the square root property, but not until I isolate the base. Yes. So I'm going to divide both sides by 3. Divide this side by 3. Okay. And then I'm going to have x squared is equal to 25. Very nice. So then I want to take the square root of both sides. But I'm not going to forget the plus or minus. So I take the square root of this side, and I take the square root of that side. And then here we go. Yeah. I'm going to get x is equal to plus or minus the square root of 25. Premature flower, but for separation. Yes, I know the square root of 25. X is going to turn out to be plus or minus 5. Now when I write that plus or minus, that's actually two cases. One where 5 is plus, and one where 5 is minus. Let's come down here. Yes. So now I'm down here. Oh no! What are you going to do? I'm going to take the square root of both sides. Yes. I'm going to take the square root of this side. I'm going to take the square root of this side. Okay, so then I'm going to have x minus 3 is going to be equal to, I'm not going to forget the plus or minus square root 5. Yeah. Okay, now I need to still solve for x. Right. Extra level of difficulty. So then I'm going to add 3 to both sides, and here's how we do this. So then x is going to be equal to 3 plus or minus the square root of 5. Okay. Right, and I'm going to leave it in this nice tight package. I could break it up into its two cases, 3 plus root 5 and 3 minus root 5, but I prefer this. That's why I give it a box and a flower. I'm going to take it over here. Okay, here, let's get an extra layer of difficulty added on. Here we go, here we go. I'm gonna take the square root of both sides. But when I do that, I'm not gonna forget the plus or minus. So then, I have x minus 7 is equal to plus or minus the square root of minus 4. Oh no! That's not real. That's not real. Yeah, so then you're gonna have x minus 7 is equal to plus or minus, what is the square root of minus 4? Yes, it's 2i. Okay, moving on. I still need to solve for x, and x is going to turn out to be, hey, look at that. I need to add 7 to both sides. So then it comes over here, plus or minus 2i. Okay, Ay, ay, ay. A box. And a flower. I got one more for you. I'm coming down here. Yes. Oh no! What are you gonna do? We're trying to isolate the base, but here we don't necessarily have that case. I take a look at that left-hand side, man. You might be thinking, well, shouldn't I subtract 4 off both sides and then try to factor, use the zero factor property and finish him that way? That may be okay. And in fact, in this case, I do believe it's gonna work. But this is an explorative example that's gonna help us with our next topic, completing the square. So let's do this. Ooh-wee, I said square. Is it? Is this a square of something? X. Is this a square of something? 3. Yes. Okay. So then this one times that one, double it. It's screaming. Perfect square. So every single time, this is x plus 3 squared. That's going to be equal to 4? Sure. Finish him. In fact, you know what? You finish. We turned something that we didn't know how to do into something we do know how to do. You know?